All right. Well, very good afternoon to our speakers and all participants. Welcome to our COASTAR webinar titled Communicating Science for the Climate Water. Now, before we start, allow me to go over some housekeeping rules. First, please mute your microphone. We are not speaking. However, you can choose to have your camera on or off. So during the presentation, please write in the chat box and let us know if you can't see or hear anything. Meanwhile, you are welcome to use the chat box throughout. So if you have any burning question for the speakers, you can type it in the chat box. We shall go over it together during the Q&A sessions. Also, do note that this event will be recorded, and the recording of this will be made available to the participant via sharing afterwards. Now, a little bit of introduction to our project COASTAR, which is short for Empowering Malaysia's Future Leaders in Coastal Ocean Actionable and Sustainable Teaching and Research. This project was funded by the British Council and MIT, and is a collaboration between Universiti Malaya, Edinburgh Napier University, and Universiti Sains Malaysia. So this is a fellowship program that aims to empower future Malaysian leaders in coastal sustainable research and to foster new network among earlier career researchers, academic mentors, and relevant stakeholders in coastal-related studies. So under the mentorship of several outstanding multidisciplinary research from the Independent Napier University, Universiti Malaya, and Universiti Sains Malaysia, the COASTAR fellows were engaged in a year-long series of empowerment and capacity building training modules. So this program will ultimately pioneer the development of a functioning coastal sustainable project that will deliver climate and development benefits. So for today, we are proud to have two speakers that have been prominently engaging on the topic of science communication and climate change actions. We have Professor Dr Chan Ngai Weng from School of Humanities, Universiti Sains Malaysia, who was trained as a geographer, a field that focuses on human-environment relationships. His research interest is mainly on the water resource management, environment resource and hazard management, climatology and meteorology. Next, we have our very own Associate Professor Dr Helena Varkkey from Department of International and Strategic Studies, Universiti Malaya. Her area of specialization is political geography and environmental politics in Southeast Asia. Now, first, I will welcome Professor Chan to introduce himself, then shortly followed by Associate Professor Dr Helena. Yes, Professor Chan.
Oh, thank you very much. First of all, I would like to express my heartfelt thanks to the organizers for inviting me to share some of my experiences and research with the group. So I hope what I have to share with you will benefit you. But if not, then at least we have a good exchange with one another. I think there is not much to talk about myself. Perhaps you can, from my slides from the talk, you will be able to know what kind of work I do in. Okay. Besides academia, actually, I am also very active in the social and NGO arena, leading Water Watch Penang, which is a water NGO in Penang. But our reach is far beyond Penang. We also look at the national and international areas. So, like Dr. Lee said, my research interest is mostly in terms of water, water hazard, and environmental hazards. Okay, thank you very much. Look forward to interacting with all of you.
Thank you, Professor Chan. Now, next we have Dr. Helena for her to introduce herself.
Okay, thank you very much, Sun Long, and thank you, Prof, as well, for joining us on behalf of the COASTAR team. We are also very happy and very pleased to have you. You were the first name on our list when we were looking for someone who was an expert on water, and we're so happy that we managed to get you. So thank you so much. So as mentioned, I'm also part of the COASTAR team at University of Malaya. Well, my background is international relations, but as Sun Long has mentioned, I focus on environmental politics. So for many years, I've been looking at transboundary pollution issues, including, or rather specifically on haze pollution, air pollution. So my specialization is not on water, but I have increasingly been involved with climate change, climate action, climate policy over the past few years. So of course, water issues also is included in this broadly, but that is sort of where I come in. So more on climate action. And you will hear about a project that I headed along with some of my other colleagues in UM and also University of Nottingham on bite-sized climate action. So that's what we'll be focusing on as an example, I guess, of climate communication or science communication. So looking forward to speaking to all of you and having a good discussion and sharing. Thank you so much.
Thank you, Dr. Helena. Now, without further ado, I will now welcome Professor Chan to go over his presentation. Now, Professor Chan, the floor is yours. I shall stop sharing and you can go ahead and share now, Professor Chan.
Okay, thank you very much. Wait, I was pressing the wrong button. Oh dear.
It's okay. The button should appear on your middle lower.
Are you seeing my slides?
It is loading.
No, that's loading. Not the one. Goodness.
I think we seems to have lost Professor Chan. Okay. Okay. One moment.
I'm terribly sorry.
No worries, no worries.
Desktop. I should share the screen share desktop, right?
Yes, yes.
Okay, you see it?
Yes, yes. We can see your slide now.
Okay, thank you very much. First of all, thank you very much to Dr. Lee and COASTAR and the team for inviting me. It's my real privilege to be able to share some of my research with you young guns, young guys, and up-and-coming researchers, whatever your field may be. So today, the title of my talk is Climate Change and Water. Basically, the interactions between climate change and water. So this is the outline of my talk. So far, may I just check whether it's okay, the sound and things like that?
All good, Prof. All good.
Yes, thank you very much. Okay, first of all, introduction to climate change. I think there is no doubt that climate is changing and there are proofs everywhere. So maybe it serves to remind us that we need to change our way of life, not just individuals, but also government, private sector, hotels, businesses, factories, and so on. Everything has to change because climate is changing. And if we don't adapt to it, we are going to be hit very, very hard, and we will regret it. So actually, this is not a new thing. We have been reminded years and years ago by people about climate change that we need to take action. But humans, as you know, human nature, perhaps overemphasis on economy, overemphasis on development, we are bypassing and neglecting what we should do. So that's why today we are still in the midst of climate change and affecting us very, very negatively. So because my talk is related to water, so climate change, inevitably I have to talk about the negative effects of climate change on the hydrological cycle. Now, the natural hydrological cycle is very, very different from this one I'm showing you. Because in the natural cycle, you don't have all this pollution, you don't have, deforestation, you don't have concrete surfaces all over the place, and basically you get, water coming down as rain, going into the ground, being absorbed by the forest and so on, and everything is natural. But when you have human involvement, when you have deforestation, rapid urbanization, and you change the whole land use, you change the whole hydrological cycle, and it becomes really, really bad, resulting in a lot of negative effects. We are not only getting heavy rainfall, we are not only getting heavier storms, we're not getting flooding, we're also getting, on the other hand, very dry conditions, El Nino, drought conditions, and this causes a lot of problem, because don't forget, if the natural system is affected, if the natural systems are breaking down, they will affect human system, because the human system depend on the natural system for a lot of resources, for a lot of things, like water, like rain, like wind power, like, you know, the soil and so on. If all these things are collapsing, then human society will suffer. Now, the Malaysian scenario of climate change is like this. These are not my research, but research carried out by researchers in other institutions in Malaysia. I just use them because they are from renowned artists, researchers. The temperatures are increasing. Whatever model you use, it is between 1 to 3 degrees increase in temperature expected for Malaysia. And in terms of the increasing number of days with extreme wind, increasing number of storms and so on, it is also increasing. So when you get more storms, when you get heavier rainfall, you are going to get a lot of flooding, you're going to get more water coming down, you're going to get a lot of problems. So basically for the Malaysian scenario for climate change, what we can expect are three things. One is getting hotter and hotter and hotter. We have a lot of heat waves, and it's getting drier between 2020 2029, and then there will be increase in storms and extreme rainfall periods. Because it may be contradicting for me to say that, you know, sometimes we are getting drought, sometimes we are getting flood. Why is this happening? Because of different seasons, spatially as well, different areas, different seasons. Some areas will be drier, some areas will be wetter, that sort of thing. So these three things we can expect. So these are the three things that we have to adapt to in the future if we are to address climate change and not to get the maximum impact of the bad effects and negative effects of climate change. We have to address these three things. So let's just look at the major water issues in Malaysia before I move on to the final part, which is on the solutions of how we can address climate change in relation to water. I have identified 6 things. The first one is a single approach of top-down supply management. In Malaysia, we are still largely dependent on this top-down management. Then there's deforestation, water pollution, low water tariffs, high water loss due to non-revenue water, and also too much water is being wasted, and of course climate change itself. Okay, even until now, we are still largely dependent on supply management. Now, in the past, this works very well because population was small, you know, towns were small and cities were not that big. So rivers were also not sufficiently or 100% being maximized. Maybe the river has 1 dam. You can build a maximum up to 5 dams, maybe for 1 river. So you can always use supply management during a time like this in the past, 20, 30 years, maybe 40 years ago. But now no longer is the case. All the rivers, I wouldn't say all the rivers, I would say the majority of the rivers in Malaysia are almost at the maximum capacity. We have built all the dams that needs to be built. So there is no more extra dam that can be built. So we can't use this system anymore. You can't, you know, build houses, build settlements, build factories, and then ask how much water we need, then we build a dam. You can't build a dam anymore. So that's why now we have interstate transfer of water from Pahang to Selangor to Putrajaya, and Penang is asking water to be transferred from Perak and Kedah. and so on and so forth. So many states are rich in water, but other states are also poor, like Penang, Police Malacca. We have insufficient water. So deforestation is another big issue. I don't have to go through the details, but you can read it in the papers. You see it as researchers. I'm sure you've come across many articles on deforestation, on the effects of deforestation and so on. But just to give you a rough idea, in the past, in the 1990s, about 90% of Peninsular Malaysia was forested. But now, I think it's less than 40%. So despite efforts at reforestation, we are still hovering around 40%, which is not good enough. I think we should be at least 50% forested. When you cut down the forest, a lot of problems, because you are destroying the water catchment. The water that we have comes from forest. Without forest, we have no catchment. And if you urbanize the area, you change the land use from forest to urban, your rainfall will also decrease. This is exactly what's happening to Penang. Our research has shown that the rainfall actually has decreased substantially, about 20 to 30% decrease over the years, because we have lost the catchment. Water pollution is a very serious problem. More than 50% of our rivers are polluted. Why do I say rivers? Because 97% of our water resources are actually from rivers. The tap water that we use, the water that we drink, 90% is from rivers, and we are killing our rivers. 50% polluted. I'm not saying this. The ministers are all saying this. Serious problem. If you can see, more than 30% of our rivers badly polluted. The clean ones, maybe less than 50%. And every year we spend millions of ringgit to try to clean up the river. But this is not the solution, because if people keep dumping garbage into rivers, you clear out 10 tons, they will dump in 20 tons. You're not addressing the root cause of the problem. The problem is in the people. So education needs to be done for this. Yes, this is another problem. Our water is too cheap. I only pay about 5 ringgit per 2 months for my house water use. It's not even enough to buy a meal. So how can you ask people to save water when the water is so cheap? Malaysia is one of the cheapest in terms of water, the water tariff in the whole world. If you go to countries like Denmark and France, you are paying about $10 per cubic meter. Malaysia is only 10 cents, 10 US cents. This is ridiculous. I think we need to relook, at the water tariff. I'm not saying that we should increase it to the extent that we, deprive the poor of the water, but at least to make it at cost effective, which means that we should not subsidize in terms of water. So low water tariffs, it's all not just in Penang, it's all over Malaysia. The average in Malaysia is at 68 cents. Penang being the cheapest. Johor is the most expensive. So that's how much I pay for water, 5 ringgit. You don't believe me? Maybe now my water bill has gone up a little bit because I'm planting vegetables in my garden. So I use quite a lot of water. But having said that, I also have rainfall harvesting system in my garden. So Penang must give cheap water because we are trying to attract industries to Penang. So one of the things that we want to attract is to offer cheap water to the industries. But this cannot go on forever because Penang is actually a water poor state. And PM says no increase because now times are hard for the citizens. Water politics is a big problem. It's one of the issues, but I'm not going to discuss about this. This is beyond my area of expertise. Maybe Dr. Helena can look into, the water politics part. This being one of our area. So we have per capita consumption is very high. Penang is more than 400 liters per person per day, whereas many other countries are less than 100. Singapore is 150. Some countries like Syria, less than 100. Haiti and Gambia is only 3 liters per person per day. My gosh, how can you have a shower with 3 liters? This is what's happening. We are using so much water. wasting so much. And our non-revenue water, which is the water lost through pipe bursts and so on, is also very high. Malaysia, on the average, is about 34% now, which means if we treat 100 liters of water, 34 liters is lost in the pipe, lost through pipe leakage and so on. This is really unacceptable. We need to, solve this problem. If we have solved this problem, actually, we've solved a lot of water problems in the country. So climate change is a serious problem now, and it's getting hotter, it's getting drier, it was a big increase in storm and so on and so forth, and we have to address these three issues. So my proposal through our research in USM and with other researchers in the country is to propose the use of blue cities. So what are blue cities? Blue cities actually is not a new concept. Bangkok is using it. Many cities in China. China is going into it a big time. In Malaysia, we also have this system. It's called the MASMA, or the environmentally friendly drainage system, being proposed by the JPS, and is now mandatory now. In the sense that if you're a housing developer, you build a new area, housing estate, you need to implement this system of underground drains, green drainage basically. Sponge cities means the cities absorb water. Sponge, you wash your plates and crockery with the sponge. So the cities act like a sponge to absorb water. But most cities cannot be sponge. You know why? Because they have deforested. There are no more forests. So what you need to do is to make the city green. Many city areas, the surface, you must allow the surface to be pervious, to allow the rainfall to seep into the ground, something like that, more areas that are blue areas, lakes and so on and so forth, retention pond, so that the cities will be able to absorb the rain. So based on our research, I'm just going to share the results now. Why do we propose the sponge city? Basically, it's a 3-in-1 thing. The sponge city will control flood, will control drought, and also will control heat. So I'm going to look at each one of these individually. First of all, flood elevation. Now, biological, ecological drainage system is environmentally friendly stormwater management system. You can look at the pictures here. You don't see any drains like the monsoon drains that we have. In many big cities, you have monsoon drains. In the past, this was the solution. This was the approach to drain away the water as much as possible, as fast as possible, using monsoon drains. But now, because cities are very, very crowded, the drainage system, urban drainage system using monsoon drains are not sufficient anymore. And rain has increased because of climate change and so on. That's why we have to now change the approach to try to store the rain at source, which means when the rain falls in one place, that place will have to be able to store the rain as long as possible to allow it to flow slowly in the ground, underground, slowly into the river, so the river has sufficient time to drain away the excess water. But if you have open monsoon drains, the rainwater will get into the river very fast, within minutes. Huge volume of water getting into from the drains into the river within minutes, and the river cannot cope with such a huge volume. And that's why we get a flash floods. But with biological drainage, you can do this because the rainfall is being stored. It flows slowly underground over various regions, various areas, detention pond, underground drain, and so on, before entering the river. So the river has plenty of time to drain away excess water. So I think this diagram clearly shows what a natural forest can do and what an urban areas cannot do. Now, in the natural forest, you see there are lots of natural processes, intersection of rainfall, leaf flow, trunk flow, root flow, and absorption and infiltration into the ground. So there are lots of the rain. Maybe during the dry season, even 100% of the rainfall is actually absorbed by the vegetation, absorbed by the ground, and none flows into the river. But during the rainy season, if less than 50% will get into the river. And slowly, the time for flowing into the river is slow because of all these natural processes. But when you urbanize, when you cut down all the forest, this is what happened at the bottom. The rainfall comes down very fast, gets into the river, and the river will flood. As you can see from here, if you deforest, increase area development, your velocity increased. Your Q discharge is the amount of water will increase nearly 200%. And your velocity increased 2 times. The water gets into the river very fast, twice as fast. The time of concentration is decreased, which is, the peak. Your peak flow will be half. The peak becomes very fast. So you flood. Here is a rural area, you don't get flooding because, the peak is very low. So how does flood situation help in reducing flood? Basically through quantity control. Control the quantity of rainwater, the quantity of storm water, and also quality control. Because when the rainwater flows over the ground, it is polluted with all sorts of pollutants. But when it flows under the ground, the soil acts as a filter, it will filter. So when the water comes out before entering the river, the water is of very good quality. Maybe class 2, class 3. But in the beginning, it could be class 4 or class 5. So lots of things. And one more is the aesthetical value, where it looks very nice, aesthetical value, and I think safety as well. Because monsoon drains, if you recall, many times you get accidents, children falling in, even accidents, cars driving into the monsoon drains and things like that. But with these underground drains, it's very safe. Okay, because there are no big drains. So the safety factor is also there. Okay, so that's how we control the flooding using the green drainage. Now let's look at drought control. Now, as I showed you earlier on, Malaysia in the future will also suffer from different areas will suffer the drought. Different seasons also will have El Nino. So this is what is happening already. It's not in the future, it's happening now. All these are actual events, okay, of what is happening. Although some of the pictures I've taken is not from Malaysia, those at the bottom are from Malaysia. So one of the things about using sustainable urban drainage is it has a component of rainfall harvesting. So when you harvest rainfall there are 2 types. You can harvest rainfall from rooftop and from ponds. From ponds here, yeah. So you trap the rain in the pond. It can be dry pond, it can be wet pond. This is detention pond in a housing area. I think most housing area must have a detention pond. Actually, you can build the detention pond as a recreational field so that it serves many purposes. During the dry season, when there's no rain, it is a football field. People can play football and so on. But when the rain comes, part of the water in the river is channeled into the pond and it floods the pond. So from a football field, it becomes a pond during the wet season. So this is the pond system for rainfall harvesting. This is my house. I have 2 of these units here from the rooftop. Small, but workable. And then this is USM, where we also have rainfall harvesting. I'm going to share with you some examples. I think these are the various components of rainfall harvesting. In the green drainage system, you need to have a roof, a conveyance, you have the storage tank, and then you use the water. Not advisable to use the water for drinking, but if you have a good filtration system, you can theoretically you can filter it and you can drink it. But I think in Malaysia it is suitable for using for washing, for flushing toilet, for gardening, for washing. It's really good. So this is the example in USM. We have 6 tanks and 6 buildings. Each tank is about 10,000 liters. So before the rainfall harvesting installation, you see that we are using 160 cubic meter per week. This per week for 1 building. C20 is 1 building. But after the installation of the rainfall harvesting as well as water saving equipment, the thing has gone down substantially to about 40. So the reduction is almost, from 160 to 40 or 50. Very, very good indeed. A lot of water is safe, huh? And we are now using this water for gardening, for washing cars, and for flushing toilet. This is another project in the apartment, N Park apartment. They also have 6 tanks. This project is between Water Wash Penang, JPS, the PBA, and also the N Park Resident Association. And as you can see, the results are quite good. They managed to save for the month of May, 3,000 ringgit. Then here, for the month of July, also 3,000 ringgit. But the amount of water saved is quite big as well. From, I can't see the figures here, 130 down is basically half, you know. Okay, sorry, here, 37% and 36% of water saved. Very successful project. So the rainfall harvesting will address also your sustainable development goals. Mostly sustainable development goal number 6, which is clean water and sanitation. Sustainable cities 11, and also life on land. Maybe some others as well, education and so on. Okay, lastly, this is the last result I want to share with you. Is very interesting to alleviate global warming is the heat. Green drainage system, actually we can control the heat from global warming. So as you can see, very, very nice and very, very green. Urban heat island effect is a very, very real. What this concept shows is in the city center where you have the most building, the most people, the most vehicles and so on, everything concentrated in the city center, businesses, everything. So eventually the city center is the hottest area in the whole city compared to the outskirts. So as you walk from the outskirts into the city center, you see that, you know, temperature increased by more than about maybe 3 degrees here for this case here. But if the city is bigger, the difference is bigger. I think for big cities like Tokyo and London and Beijing, the difference may be about 10 degrees Celsius. For small cities like KL, maybe 2 to 3 degrees. And you may be wondering why is the big problem heating? You know, we are already hot in Malaysia. 1 or 2 degrees hotter will not make any difference. But we are used to the heat. But many people in the cold countries, they are not. They are not used to the heat. Like in this case, 2003, a lot of people in Paris died because they couldn't stand the heat for 1 whole week. They had a heat wave. And they had no air conditioning. They only have heaters. So it's a serious problem for people in temperate countries. Not so much for us in tropical countries. But every city will experience this urban heat island. City centers are always very, very hot. Now, I'll share with you some examples from Georgetown. Georgetown has increased temperature over the last 20 years of 6.37 degrees. This study was done by Think City. So compared to the outskirts, temperatures are only about, you know, averages 24, 25, but in the city, nearly 30. Okay, KL also has shown some increase, but not as much. Surprisingly, KL was only 2 degrees. I'm not sure whether this can be believable. I was expecting KL to experience higher. Maybe we need to relook at this. Johor Bahru, same thing, 6 degrees increase in temperature over 20 years. Ipoh also, as you can see, the red areas are the areas with the urban heat island. So when you have smart city and when you have green drainage system, you are putting in a lot of green features. Not only putting in the green, the forest and the trees, you are planting trees, you are planting a lot of green things. You also put in the blue things. You also have retention pond, you have wetlands, you have rivers, lakes. Compared to this one here, this whole concrete jungle, all the red stuff here, dark absorbent surfaces, lack of vegetation, low rates of evapotranspiration. The evapotranspiration is very important to dissipate the heat upwards. When you have all these forested areas here, a lot of the heat that is absorbed in the city can be transferred upwards. 1 gram of water will release about 600 calories of heat. It's just like our body. When we exercise, we run, our sweating, 1 gram of sweat will take away 600 calories of heat from our body. That's why we don't overheat. Imagine if you don't sweat, you run, you don't sweat, you have a big problem. Because when you don't sweat, your body heat stays inside. You don't get rid of your body heat. So this is the same thing here happening. When you have a lot of green, you have a lot of evapotranspiration, and this is a mechanism for getting rid of the heat from the city areas. So many natural processes that will make, the temperature, control the temperature. These are the results that we have. As you can see, without trees, temperature on the road can be 50, in the car 36, the building surface 43. But once you have trees, you have shading, all this come down significantly. Even on the road surface only 26, but the sidewalk is 20. So it's very pleasant. And this is done by using infrared thermometer. You can use the infrared thermometer and shoot. You can see the red ones are the hot areas. The blue ones are the cool areas. Coming to Jalan Branda, Georgetown area also, which our research has shown that, without vegetation, very, very hot indeed. This part of Brown Road has a lot of trees. This part in Georgetown does not have. So Penang has a plan, has a project to try to make the city green by planting lots of trees, maintaining all the green areas, building a green park and so on. That's why I think, all the big cities like New York and London, they have big parks, Central Park and Hyde Park and so on. But most of our cities in Malaysia, we don't have. Okay, now when I was in KL, living in KL, actually I was from Universiti of Malaya, the geography department for 9 years in the 70s. Those days we have the Bukit Nanas. Bukit Nanas was very green. It was the green lung. But now I think Bukit Nanas has already been developed. And also the Lake Titiwangsa area was also very green. And now also is being encroached upon. So Penang is trying to, put in all the green stuff. As you can see, these are the examples from elsewhere. Greening, urban farming, every available land in the cities, in the Japanese, they plant. They don't just plant flowers, they plant things that can be eaten, edible garden. So, which we need to learn from the others. So in conclusion, I think for the three main effect of global warming, heat, flood, and drought, we can combat it by using the blue cities, sponge cities concept. There is no doubt that climate change is occurring and it's affecting water resources negatively, not positively, negatively. So based on Malaysia's climate change projection, we must address the heat, the floods and droughts in the future, if not now. Yeah, our current research shows that sponge cities have great potentials and should be used as an adaptation to climate change, even as a mitigation to control flood, drought, and heat in the cities. There is no doubt that you need to do something. We need to do something. Our research has shown that the sponge city concept can alleviate flooding, can alleviate drought, can also alleviate and control the heat in the cities. So it should be used as a tool for most cities to control these three effects of climate change. And if we control these three effects, we would go a long way towards achieving our SDG, basically SDG 6, 13, and 11. So thank you very much for your time, and I'll be happy to answer some questions if you have. Thank you very much. Back to you, Dr. Lee.
Thank you, Prof Dr Chan, for your knowledge sharings, highlighting on the serious threat of climate change to us all, and also sharing some of the ongoing efforts to help mitigate the issues. All right, before we, I'm sure some of the facilitators have some questions for Professor Chan, but I think we will leave this after to the Q&A sessions. All right. So for now, allow me to welcome Associate Professor Dr. Helena to share her insight on communicating for climate change, on how can we help to raise the awareness the issue to others. All right. The floor is yours, Dr. Helena.
Okay, thank you so much. Sunong, can you please share my slides?
Yes. correct?
Okay, thank you so much. So I'll spend about 20 minutes just talking quite generally about the importance of science communication. So Prof has already shared with us a lot of information, factual scientific research and solutions on how we can sort of look at water as well as other elements in the ways to address climate change. So I will be spending some time talking about how we can communicate this to people and why it's really important. Okay, so next, please. So we're going to start with what is actually science communication. So science communication, if you want to look at it in terms of the definition, it's a variety of practices that transmit scientific ideas, methods, knowledge, and research to non-expert audiences in an accessible, understandable, or useful way. So basically translating scientific ideas into something for the general public. And this is meant to build the bridge between the people involved in the science and to the public. Okay, so an interesting quote that I got here was to enhance public awareness of science, increase enjoyment and interest in science, technology and engineering, and inform public understanding or opinion of scientific endeavors. So that is what science communication by definition is. And the next slide, please. Why is it important? So I think most of the people who are here today are either scientists or those who are interested in science. And this may be a bit different from the general public. So if you are not a scientist, where do people usually find science? Okay, so they may just hear about it in school. And after you pass out of university, you kind of don't really engage with science very much anymore, or at least you don't think you do. If you are a scientist and if you're actually working in science, you may know a lot about your specific area, but maybe not very much beyond that. So if you're a water expert, you will know a lot about water. If you're an air pollution expert, for example, you know plenty about air pollution. But if someone asks you something like, something maybe like if you ask me about sea level rise, I may not know much about that and I may not be very confident about that. So in that way, the general public is quite limited in their exposure to science. But actually, science actually is very important in our lives, and it plays a very interesting and complicated role in our life, and we all need science actually. So, from the very personal kind of decisions, I've given an example here. Should I eat that pie that has been left out of the fridge since yesterday? So without scientific knowledge, you might actually just eat it and get sick, and that could be problematic for yourself. It's also really important for you to make bigger sort of societal decisions. So as a person, should I support certain things that my country or my government is proposing? Should I support land reclamation activities in Johor, for example? Or should I decide to go and protest about rare earth mining in Pahang, for example? So all this also, you need to have a good understanding of science to be able to make this kind of decisions. So being able to understand, learn about, question, and critique science is an important part of everyone's life, not just scientists. So science communication is supposed to play this role of helping people to learn about science, to understand science issues that they may hear in the newspapers or on TV, and to find your own voice and your own opinion in certain debates about science in our life. Next, please. So what does science communication look like? When we say, okay, we want to do some science communication, like let's say you're a scientist and you say, okay, I want to communicate my science to the public. What does this involve? So actually, basically, it's a very broad. So you can actually, some examples could be if a scientist or even if a common person is writing an article in the newspaper or in a magazine or in a blog about a certain scientific issue. So basically, it is not written for a scientific audience. So like, for example, scientists may write in journal articles that is really for the scientific audience. But when you want to write for the general public, it will be written in a very different way. It will be written for the masses. So when you write it with the intention to communicate to the public, that is an example of a science communication. You also see here this moving diagram. This is, you can call it an infographic, this is also a very effective way of science communication. You are translating a very concrete, specific scientific graph into something that is simplified, colorful, interesting, moving, that is not only easy to understand, but will also attract the attention of people who may not know very much about it. And it's simple enough, but at the same time, it communicates what you want to communicate. So another example is if you come and talk to people, standing in front of a non-expert audience to give a lecture, which is different from, let's say, me or Prof giving a lecture in the university. The way that we give a lecture in the university will be different than if we are, let's say, invited to give a talk at the ministry or to give a talk at the school, primary school. Okay, so how we simplify and how we adapt the knowledge to the audience, that is also science communication. And even leading workshops, doing live demonstrations of a lab experiment, this kind of stuff. When you go to, let's say, PetroScience, or you go to the science center, this may also, you will see people doing this. And these are real hands-on science communicators who are working directly with the public. So you may have heard of terms like public engagement, public understanding, science outreach. All these are all different types of science communication. Next, please. So these are a few basic steps as a scientist. If you want to learn to communicate science effectively, what you have to keep in mind. I've put this picture here because of an elevator, because it's very much like an elevator pitch. I think most of you may have heard this, an elevator pitch. So basically, this is the idea that you only have a very short time, the time of an elevator ride, to capture your audience's attention. So the elevator pitch is actually, the origin is like if you have this scenario where you're looking for a job and suddenly you realize on the way to your interview, for example, you are in the same elevator as the CEO of the company who's going to hire you. So how are you supposed to communicate in that very short time what you want to communicate to convince that person to hire you? So in the same way, how can a scientist or how can someone communicate scientific concepts to the public in a very, very short time, because the public's attention span is very short? How can they do that in a very short time to pass the message, to get the message delivered, and to have the maximum impact? So these are some steps here. First of all, you have to know your audience. The way that you communicate certain things, let's say to a group of school children, and let's say to like a group of community members in your neighborhood, for example, will be different. So you have to know and you have to adapt accordingly. Second is you have to identify your goals. What do you want to actually achieve with your scientific communication? What you may know as a scientist is very, very big, but you just have to focus on what goal you want to achieve for that interaction. So that may mean just picking one part of your research to communicate. Okay. The third is start with the most important information. Why is this important? Sometimes at university, we are taught to, give a nice introduction, sort of give your background, and then go to your theory, and then only the information or your finding comes at the very end. But for science communication, it's actually upside down. Start with the most important information, because the attention is only there for a very short amount of time, and if you don't capture them at the very beginning, they won't stay until the end. So it's very important to capture your audience right at the beginning with the important information first. Avoid jargon. So sometimes as scientists, we will have our own unique terms that we use that many people may not know of. So specific things. So I don't know whether I can think of an example in the climate change context. So for example, like adaptation and mitigation, these are quite specialized terms, but probably you all will know what it means. But for the general public, they may not. So you may need to look for another way to communicate what does adaptation mean, or when you want to talk about adaptation, talk about it in a different way. Okay, how can we live with climate change, for example? That is another way, rather than saying, okay, this is how adaptation is all about. So you have to be able to use that as well. You have to also be relatable. So you don't position yourself as a scientist that knows more than other people. Just position yourself as someone who is just like them, and try to be relatable in the way you talk, the way you dress. Yeah. So all this will also you have to think about as well. Provide visuals. Visuals are very important because people remember visuals very well. Generally, people remember visuals. So if you want to, let's say, write an article, it would be good also to select your photos that you go together with the article very carefully, or even better, if you can develop your own infographics to go along with these articles. So, for example, Canva is a very useful tool for people nowadays, accessible tool to build these kind of things. The seventh one is stick to 3 main points. Research has shown that people generally are very comfortable with the number 3 for some reason. So when you want to communicate something, you already know what your goal is. Think about 3 important points that will drive towards that goal, and then stick to that 3 things only, and don't try to communicate too much. And lastly, talk about the process, not just the results. So this is something that not a lot of people realize. Some people like to just communicate their findings, but how do you make yourself more legit, more believable, more more accountable? You also have to explain to them how you discovered this thing, or how you came to this conclusion. So spend a bit of time to say, we did this questionnaire, for example, or we underwent this this field trip, or we went to this particular community and we did some testing here. So to communicate that you actually did something verifiable that supports how we got to the results. So these are some of the steps that you can consider when you are developing your science communication materials. Next, please. So, as a scientist or as someone who's interested in science, can you make science communication into a career? So let's say for myself or Prof or Soon Long, we are trained, we have our higher degrees in either science. For myself, I have it in policy. And can we actually, make it into a career? Can we change our career? Can we be a professional science communicator? So definitely the answer is yes. Okay, so there are people out there who have made a career about science communication. Science communication is a field of both activity and research. You can actually even do research into how to communicate science properly, and you can also actually do the communicating yourself. So there are various ways for you to make science communication into your career. So working in science communication can involve a few things. So for example, you can train scientists to communicate their research more effectively. So for example, we may need help. We may need consultants to come in and tell us, okay, this is how you should focus. This is what you should focus on to promote your work to the public. And there are a lot of, for example, news sites, research sites that specialize in this, how to simplify complicated scientific research for the public. That's one form of, doing it as a career. You could also do experiments in front of crowds or visitors, like I mentioned the example of petroscience. If you are a scientist that loves to work in the lab, but at the same time also loves people, that could be a very good job for you. Because sometimes if you just work in the lab, it can be very boring. So this could be a very good way for you to communicate what you do in the lab. You can also do research to understand how the public thinks about scientific issues. So this is also trying to help and trying to make science communication better. So once you understand how the public thinks about something, you will also know how to communicate with that public about that certain thing. So for example, for the Malaysian audience, when you want to talk about climate change, we first have to know what Malaysians are interested in about climate change. So if you want to talk to Malaysians, you probably shouldn't be talking about polar bears and ice caps, icebergs melting in the Arctic, because Malaysians may not be able to relate. So we actually have to do research to figure out what the Malaysians care about. What is it about climate change that can connect to Malaysians? So it may be things like floods, like droughts. It's getting warmer in Malaysia, like Prof has mentioned in the previous presentation. That may be the thing that can connect the public, and then we can focus on that and build our science communication around that. So research is needed to be done on that perspective as well. And finally, we have to keep in mind that the goal of science communication is definitely to inform and to inspire people to take action, but it also has an important entertainment element. So if you think you're a funny person, if you think that, you know, you have this knack of speaking in public, you can make jokes, you can make people laugh, this is actually the elements of a great science communicator, because it is about entertaining people so that people will be drawn into you and will be more inclined to relax, listen to you, be open to what you're trying to tell them. Okay, next please. So these are some examples of famous science communicators. Immediately you can see some problems with this picture. We don't have any women and we don't have any Asians. So there may be some science communicators out there who are women and who are Asians, but perhaps I'm just not as exposed. So if you do think of anyone, please put it in the chat. We can look them up later and see what they have achieved. But these are some of the people who you may have come across before. And these are definitely people who I grew up with, that I have seen on the television. You know, in like, for example, Bill Nye, the Science Guy, was on Nickelodeon. And he was actually doing experiments and doing things for kids to get kids interested in science. And at the top right, you will see the Mythbusters. The Mythbusters was a really famous TV show. Even though it was portrayed as sort of busting myths, it's actually doing it in a scientific manner. So they are trying to engage people with science in an entertaining way. And you can see Sir David Attenborough, you can see at the bottom, Neil as well, Neil deGrasse Tyson. So they are also very popular for mainstreaming science to the public. So you can see there's a lot more room for this. Next, please. In Malaysia, we don't really, I don't think we have any person who we can really say that is a very prominent science communicator, but we have certain websites that are trying to push science to the public. So for example, Science Media Centre Malaysia is one setup that's trying to do that. We also have the Petri dish, and we have a few others as well, trying to you know, write things in an accessible manner, translate scientific knowledge into an accessible manner. And we've also had certain people who have gone for competitions and sort of won, and they've become quite known, you know, quite successful teachers have been able to actually get this sort of title. But I don't think, I mean, I think we still have room for more really prominent science communicators at a very high level in Malaysia. Next, please. So I mentioned that maybe most of you here are scientists, but actually, if you are not, don't feel left out, because, you know, if you ask the question, do I need to be a scientist first to be a good science communicator? The answer is no. For example, for me, I am not a scientist, and I think I'm still able to do what I can to try and communicate science to the public. I may not be able to explain to you in scientific terms with diagrams and lab tests, you know, why a certain thing is a problem or what can we do about it. But I can use my own expertise in terms of what I know about policy, in terms of what I know about communication, and that can also be useful in translating science into accessible things, okay? So what is really important is that you should be able to understand the science yourself. If you don't, ask a scientist friend to explain to you, or do your reading, you know, do your own effort. So once you yourself can make sense of the science you want to communicate in your own words, then only you'll be able to communicate it to others. Okay, so for example, for me, a lot of my time is actually taken up reading scientific articles about air pollution, you know, not only reading about ASEAN or the government policy, but really reading about the scientific angle of the problem itself. It will take some time. It's not always easy, but we need to do that. Okay. Of course, education and training in science helps, but it's not actually a requirement. Just like my own experience. And as with communication in general, doing science communication well is a matter of practice, meaning that the more you do it, the better you become, the more confident you become, and the more you are able to understand your audience and shape what you want to communicate better. So some of the useful skills that you should have: willingness to learn. Just because something is a bit foreign to you, don't be scared to try, to read, to understand, to ask questions. Grasp of media skills. It's very good if you know things like Canva. It's also very good if you have some journalistic training, or if you know certain basic media principles, like how to write a good headline. This kind of stuff is very useful. And of course, storytelling is important. Getting people to understand science is very effective if it's done through a story. What is the story you want to tell? Yeah, so people are generally attracted to stories as well. So if you're able to make it into like an interesting journey for them, or relate it to something like that, bring a story, bring characters, bring a human face into what you're trying to communicate. This is going to be very useful. Some universities do, however, offer postgraduate degrees in science communication. So if you're really serious about it, you can actually look for some of these universities that you can get a degree or a postgraduate degree in science communication. Okay, so I do see some questions in the chat, but we will hold on for the Q&A for that. Thank you so much for putting in the questions. I'm really happy to see there are questions coming in, but we'll proceed first. Next, please. So that was what I wanted to cover about sort of the art of science communication. And now I'm going to spend a bit of time on the Malaysian context, and what we know and how we can use this, our knowledge, to try and communicate with Malaysians a bit better. So this is quite an interesting infographic that was developed by UNICEF based on a research that they have done among youths in Malaysia. So you can see already, this is a type of science communication because it's done in a very simple manner, attractively, simple to understand graphics, and you don't need to be a scientist to understand what is trying to be communicated here. So according to this survey, 92% of young people in Malaysia think that climate change is a crisis. So we are all, the youth in Malaysia, are worried about climate change. But the second point here, the survey respondents reported that they have a fairly good to very good level of understanding of climate change. So what the problem here is that there are some confusion on basic scientific climate concepts. So the issue here is that there is still a lack of understanding on important scientific issues related to climate change. So what this means is there has to be more and better communication to the public to make sure the public understands basic scientific climate concepts. Okay, and then there are some other interesting information here. 9 out of 10 Malaysian youth have experienced environment and climate related effects in the last 3 years. So we cannot think of climate as something very far, climate change is something very far away. The great majority of those surveys said that I myself can feel the difference in the past 3 years. So it's definitely happening. And 9 in 10 youth are already taking individual actions to address climate change. So this is very promising. People are actually doing things already, okay, on their own personal level. Next, please. So I want to introduce you now to Bite-Size Climate Action, which is a project that me and my colleagues, we came up with. We created a website, okay, that is targeted at Malaysian youth, but actually is for everyone, to try and promote better understanding for climate science, okay, from a Malaysian context. So we're not talking about polar bears, we're not talking about icebergs, we're talking about Malaysian things here. And we thought that this was a gap that we needed to address, okay? And the other thing about it is it's bite-sized, it's short, it's sweet, it's snappy. So this is what we thought, to communicate science, it has to be bite-sized, simple. People need quick information and they don't want to spend time reading a long article, for example. So we used the youth, we tried to understand our target audience, and because we understood it, youths, we tried to use the medium that's appropriate to this audience. So for example, we use TikTok, we use Instagram. So we know that, maybe the youths are not so excited about Facebook nowadays. So we focus more on the ones that we know that youths are more open to. We also focus on personal actions. We don't want people to think of climate change as something that is a government's responsibility or something that is too big for you to handle by yourself. We want to show that every single small action counts. So focusing on personal actions. And we also made it small in the sense that we have 6 modules, but they are standalone. So we have, I'll show you later, but each module means that you don't have to do cover the whole thing for you to understand what you can do for the climate. If you're interested in electricity, just do our electricity module, and that's enough for you to know what you can do. So we try to make it more accessible that way. Next, please. This is some information more about our bite-sized climate action. So we have our 6 modules here, and we also have the types of content. We have videos, infographics, podcasts, social media, quizzes, resources, all in very bite-sized kind of approach. Next, please. Okay, so now I'll basically end my lecture here. So now you can stop sharing. I'm going to try and share my screen over here to show you the website just very quickly. So let's see if this works, because my computer was problematic earlier. Okay, so I hope you can see. So Long, can you give me a... Yes. Okay, so this is our website. So you can see the address here as well, bitesizeclimateact.wixsite.com/Malaysia. So you will come to our front page here, and then we have basically three main sections: the basics, our modules, and some lesson plans for educators. Okay, so basically in our basics, we have some very short lectures that will show you, that will give you some basic understanding about the science behind media action, behind climate action. So let's see if, yeah, here it is. So you have some mini lectures, you have an infographic, and you have some follow-up readings. This is not like, you know, if you don't want to do the basics, you want to go straight to the modules, it's also fine. And like I was saying, we have modules on 6 different areas of climate action. And I will try and go in here. And our 6 areas are electricity, forest, food, waste, as well as change. Okay, so it doesn't seem like it's opening up. Oh, there it is. Okay, so let's see. We can go into one. So like I said, you don't have to do everything to know what you can do. Each one, if you're interested in electricity, just look at electricity module, and this module will hopefully give you enough information to understand about how electricity is connected to climate change, what's the situation in Malaysia, and what you yourself can do to contribute to a lower impact in terms of electricity. So we have podcasts, we have our video, 3-minute video, very fast, infographics. We even have our TikToks, yeah. Hold on, it's a bit stuck on my side. We have our TikToks and as well as our quiz, so you can actually test your own understanding on that. Okay, so I won't waste too much time, but please go ahead and have a look. And the newest thing that we've added is actually a calculator where you can input your own personal contributions, and you can actually see to what extent your climate impact is, and actually which area of which module you should focus on more to make your own most positive impact. So let's say when you do our calculator and then you find that your impact is highest in waste. So then the idea is then maybe you should start with the waste module, and then you will then be hopefully inspired to make some changes from that perspective. So the calculator is here. You just input, you know, your transport, what kind of transport do you use, what kind of food do you eat, you know, you can put all this in, and then you will know which is your highest impact, which area among the five modules is your highest impact, and then you can make decisions based on that. So this is an example of a type of science communication activity or a science communication method, a website where, you know, people can freely come and do things and learn and share as well. So I think I will stop here for now. And then we can go on to the question and answer session. So hopefully that has been useful to some of you. Yeah, let's stop here for now. Thank you.
Okay. Thank you. Thank you, Dr. Helena. So, okay, thank you, Helena, for sharing your insight on the communication on how to actually convey our research to the publics. So right now, in one hand, we actually have all the sciences, all the information from Professor Chan on the problems of climate change, the consequences, and what we can do about it. And then on the other hand, we have insight from Dr. Helena on how can we communicate this information, our researchers to the general publics, and how to generate more traction for this so that we can actually gather to fix these issues, climate change issues. Now, let's move on to the Q&A session. Dr. Helena, can you stop sharing for a while?
Oh, sorry, let me stop. Okay.
Yes. Okay, so yeah, right now we are at a Q&A session. So so all the participants, if you have any questions from both our speakers, you can turn on, wait, let me allow everyone to turn on their chats now. Wait, sorry, turn on your mic. Okay, now everyone now have the permission. They are able to turn on your mic to ask your question live. Or you can, if you are too shy to do that, you can actually type your question in the chat. So currently, I see in the chat box, I see some questions. Okay, we have one from Mr. Siti Vinayakam asking, any opinion about the effectiveness of using art forms for communicating science of key issues to non-expert or publics? I believe this question is directed to Dr. Helena. So,
Yeah, sure. But you know, if Prof Chan also has some examples in Penang, I know a lot of things are happening in Penang. I would love to hear it as well. But definitely, there have been many instances of people using art. So, for example, Greenpeace is a good example. So, Greenpeace, they collaborate with artists quite a lot, graffiti artists, you know, and they would, you know, they call it, I can't remember what it, I think like guerrilla art or something like that. So they actually would have art installations around town, which will attract attention. So it's usually something that the point is to attract attention to the issue and make it memorable to the people who are viewing it, with the hope that eventually the people will go back and read a bit more about it. There's also a famous artist called Ernest Zakarekovich, if I'm not mistaken. I've been in touch with him before. He does a lot of art to do with forests. So what he did before was he actually took an old palm oil plantation, and he actually created the words SOS in the plantation, like by cutting down trees and stuff, and took pictures, and it was quite a sensation. So it just calls attention to the issue. And that is what art can do, and then inspire people to read more about it. So that's definitely one interesting way that can be done. Thank you.
Okay, I have some examples to share in this particular instance about using art, not with my scientific research, but actually with my NGO. Our NGO work, Waterwatch Penang. There is this lady who is in a dancing. I think her name is Aida. She has a group in Penang, and she would use the river as the dance theater sort of thing. And her communication is basically to communicate to the public what we are doing to the river, what is the river used for, and it's actually very interesting. And they do the dancing in the river itself, which makes it more interesting. So I think many times when we have activities in the river, we bring students and so on. We have actually asked them to come along, and the kids, they enjoy it very much. Also, having said that, sometimes we have World Water Day. We would have competition, drama, dancing, anything, but the theme is water. So these kids who participate will have to come up with something, either the drama, either dancing or singing or whatever, or even a poem or pantun, but related to water. So it's kind of an art form, you know, getting the environmental message across. So thank you very much. You can definitely do it, yes.
It's great
Thank
examples,
you.
yeah.
Thank you. Thank you very much. I hope that answer a question for this city Vinayaka. Okay, next we have another question from Miss Lian Lin T. All right, this is to Dr. Helena. She was asking, how do you feel about using humor in science communication? Do you feel there's a risk of trivializing the argument you're trying to make? Yeah, this is interesting.
This is a very interesting question. Yeah, I mean, you've pointed out exactly the risk, yeah, to trivialize the argument. But I think humor is part of entertainment, and entertainment is the way where you attract people to come and listen to you, to be inspired by you. And if you see some of the examples of the science communicators that I've put up, they are actually quite humorous in their manner of speaking. So, for example, like with the Mythbusters, they are almost like a comedy show. Actually, you know, they have big explosions. You know, they exaggerate certain things, their expressions. You know, all this. And for example, like David Attenborough, even though he is, you know, quite a serious, you know, old British person, he's quite witty in his speech as well. And likewise with Bill Nye. So I think humor is definitely great if it can be done well. Sometimes humor is used to trivialize things in a bad way. I would say that sometimes it has been used, for example, in the anti-climate change movement, you know, to sort of show that, to sort of imply that, oh, it's nothing really serious to worry about. Like, what's all this worry, what's all this nonsense, is unnecessary. So if it's used in that manner, of course, it can be dangerous because people understand humor, or the humor is something that people can understand easily. So if humor is used in the wrong way, they can understand things wrongly. So I think, but you know, people who are doing legitimate science communication should also harness that tool for themselves to also combat against the bad humor that has been used on the other side lah. So we must also, you know, engage with the same things as what we are trying to push back against. So I think there's nothing wrong in using humor, but it has to be done well. And the main point, you know, the main goal that you want should still be clearly set from the outset. I'm not a very funny, I'm not a funny person or anything like that. But I do remember, you know, last time when I was in debate and all that, humor was a very important argument strategy as well. It's actually used as a strategy because you do want people to connect with you and laugh because it shows that they are on your side. So if you can make people laugh, you can definitely a higher chance of them making people to believe you and commit to what you're trying to say. Yeah, I don't know whether Prof would have any additional to that.
Okay, I actually a bit skeptical about using humor for the sake of science because I don't know. Yes, you attract people maybe in the beginning using the humor, but when you communicate the science fact and the data, you know, you should not make it into a joke. Otherwise, people won't believe you, you know. I actually, in my line of work with my NGO Water Watch Connect, we have a long considered using humor and engaging the comedians like Harith Iskandar to come and, you know, talk to people and things like that. But of course, eventually we didn't get it through, not because it didn't work, because it was too bloody expensive. I'm sorry. if they could do it for free, I think it would be great. I think I can pack, you know, the room full of kids, you know, if he were to come. But of course, I think we cannot afford him. It can be done. Nothing is impossible. Yeah. Thank you very much.
Thank you. Thank you. Okay, on the topic of communication, we have another question from Marian about science communication as well. So she said that she felt that a lot of science communication is targeted to the youth, but what are some methods we can use to educate the older generation? Do we think we need to target them more as they are the people in positions to make large impact decisions? Right. So
Who should answer that?
Dr. Helena, Dr. Helena, you want to answer first?
Okay, I'll just a quick one, and perhaps Prof Chan also would like to add. Actually, there was I did a research recently about how to how public understands haze, you know, and there was actually a big conversation about how the older generation understands and gets their information from, you know. So actually, one of the things we discovered is the older generation like to use WhatsApp a lot. So that is I mean, just like when you want to say youths, okay, TikTok. Older generation, WhatsApp. So you have to know what their medium is, and then also how to use that. So for example, from what we understand, older generation likes to forward things, you know, forward. So, you know, they will just forward. They won't actually, you know, read properly or click on stuff, click on links and all that. They just forward the picture. So the infographic is very important. You have to have a good infographic with the information all there already. Don't bother, don't hope that they will click the link and read more and all that. So those are some kind of strategies. And as well as older generation really likes to listen to their friends and family. They actually often trust their friends and family more than experts and ministers and government and all that. So how do we also tap that? It's a bit difficult because we can't be friends and family with everyone, but that's just something to keep in mind lah. You know, that means you can use your friends and the family of the older generation to then communicate to them. So it's like sort of a two level. So these are just some of the strategies that I have come across in my own experience about how to engage with the older generation. Prof Chan, would you like to add anything?
Maybe just a little bit. I think it's not about answering the question, how do we communicate to the older generation? The question should be really, do we need to educate the older generation? A lot of older people think they are very experienced, they know everything, you know, they are the ones who know everything, there's nothing to learn. When you start thinking about that, then that's the end of you. That's the end of you, because learning is a continuous process. Even I am also still learning. I learned so much from Dr. Helena today, how to communicate, you know, scientific facts. I've never gone through any process, any training on communication. So how I lecture is 100% based on just practice through experience, that's all. So without learning, so I think it's important that the older generation are exposed to all these new things. TikTok, you know, we should have a session of TikTok with the older generation, with a session of, you know, how to do website, how to, all these new things. Otherwise they will be left behind. We cannot leave behind the older generation, because our population is also 60% more towards the older generation. So if you leave behind the older generation, 60% you are not taken care of. So the best way to communicate is actually, you know, to educate them on the new things that they are not familiar with. As for me, I'm very reluctant to change my phone because I don't want to learn the new things. I'm really dreadful of learning new things with the new phone. But that is something you need to change, because the old phone has a lot of things you can't do, you know. You cannot carry on with this big old phone. I think I have to change also. Thank you very much.
Thank you. All right. Okay, so we still have like few minutes left until the end of the session, but we have some more questions that is related more on the urban heat islands and also about the smart cities question related. So the first one by Mr. Siti Vinayakam. This is directed to Prof Chan. How well do engineered built environment perform in mitigating issues related to urban heat islands compared to natural green belt?
Okay, thank you very much for that question, Mr. Siti. Okay, the question is not whether it's engineered or natural. Of course, you leave everything natural, the natural one is the best lah. You know, there's no doubt about it. But if you engineer the green belt in a suitable manner, according to the real species that endemic in the particular area without introducing foreign species that may screw up the whole place, that may, like control the whole area, then you are okay. So you should engage the biologists, the people with the know-how in the particular area before you plant the new species. So we cannot simply, just plant anything that you want, or build anything, engineer anything you want. It has to be done, in the right place, in the right manner, with the right species. Then I think it will work. Maybe not 100%. If you can get 70, 80% of the natural stuff, I think it is good enough. Thank you.
All right, thank you. Okay, on the topics of sponge cities, Prof Chan, do you see the concept of sponge cities are being able to adopt it in KL or other cities in Malaysia in the nearest future? And also, what is the biggest challenge to actually implement the sponge cities in Malaysia?
Okay, I think in the future, sponge cities will be accepted because we already have the MASMA. MASMA is the environment-friendly drainage system proposed by the JPS. So now it's become mandatory. That means if you want to build a new area, housing estate or industrial estate or whatever, you have to have this system. You cannot build a monsoon drain anymore. If you don't have it in your system, your project will not be approved. This is mandatory. So in the future, smart cities will be here. But the biggest challenge now is actually many of our cities are so packed, with buildings. The buildings comes next to the river. So the river really have no space to maneuver. There's no wetland, not enough space. Space is the biggest problem that I see trying to implement the smart city. But having said that, many countries like Denmark and Japan, even if they don't have space, they buy back. The government will buy back the land from the farmers and from the landowners and return it back to nature. So do our government have that commitment to buy back the land, which has already been built up, and turn it back into nature? That is the biggest challenge that I see. And space. Yeah, thank you very much for that question. Very interesting question.
Thank you. All right. Okay. So and when I look at time now, it's 3:30. So this is basically the end of the session. However, if more participants actually have more questions, you are feel free to email the question to us, and then I will direct to our speakers, and then we'll get back to you on the answers. All right. So thank you very much to everyone here, to the speakers and all the participants for this occasion, for these sessions. It was a very insightful and helpful learning session for everyone involved. So this is it. Thank you very much. And so for the COASTAR fellows, can you please stay back, because we for COASTAR fellow, we will have another session coming straight from here after this. All right, reminder on that. And then as for others, we hope you'll see again on our next webinar coming soon. All right. Thank you very much and goodbye.
Thank you very much. Bye-bye.
Thank you so much.
We'll talk to you some other time.
All right. Thank you.
We can work together. Dr. Lee
Yes.
as well.
Thank you so much.
And the other participants as well. Maybe we should take a photo. Dr. Lee.
Oh yeah, we should.
Yes.
Yeah,
thank you for reminder that. Yes. Yeah, we should take a photo.
I hate the online thing because I don't see anybody except the speakers.
Okay.
The participants willing to show themselves.